So, good morning, evening, everyone, depending where you are, and very welcome back to day two of the Newcomers for Nuclear Summer School 2025. We're thrilled to see such a vibrant and diverse community gather here students, professionals, educators, and innovators from across the globe. United Science and Technology. This summer school is more than a series of lectures. It is a living laboratory of ideas, a platform where traditional academic models meet bold innovation. Together, we are building bridges between disciplines, generations, and nations because the future of nuclear energy demands collaboration, creativity, and courage. Whether you are exploring nuclear medicine, climate resilience, or advanced reactor technologies, your presence here signals a powerful shift. A new generation ready to lead with knowledge, empathy, and vision. So let this program be a catalyst, not just for learning, but also for action. Let it inspire new partnerships, new research, and new ways of thinking. And above all, let it remind us that nuclear science is not just about atoms, it's about people, progress, and possibilities. So, thank you for being part of this journey, and let's innovate, integrate, and ignite the future together. So, just to run over the summer school requirements, we request 80% of attendance to all the sessions. In case that you are not able to join us, please just send us a message to my colleague Lancina or myself that maybe it can come a personal situation or a job situation. So just let us know that we mark the attendance for you. We'll have a questionnaire at the end of the summer school. It will be very short. It's not like heavy, actually. It's just for measuring your general understanding of the content, know how we did it or what we need to improve for the next editions of the program. That's all for these requirements. But in case that you have any questions, please drop them on the chat, or if you can open your mic, and then we will be happy to take them. And for today's program, we have a very, very, very nice agenda. We have Maria Masso from Senegal with us, and also Safa from WiNI Group from Egypt, and two great moderators, Dr. Kulu and Dr. Idrissa, joining us from Togo and Burkina Faso. So before introduce properly to our two great moderators today. So, starting with Dr. Beresa Kulu. She's a radiologist graduated from Faculty of Science at the University of Lomé in 2015. She works in public and semi-public hospitals in Togo, where she has held positions of responsibility, including head of department, passionate about the peaceful applications of nuclear science and technology, and she actively promotes them as levers for development in Togo and Africa. She is particularly committed to the inclusion of women and young people in this strategic field, convinced that nuclear energy can become a driver of equity, innovation, and sustainable development. She is the president of Women in Nuclear Togo. So we have a very great representation of the Togolese community. So now let me introduce Dr. Kedraugo Idrissa from Burkina Faso. He's a Director General of PAC Nucleus, and he's an international consultant in nuclear safety, radiation protection, and nuclear security. He also serves as a consultant to the CTBTO on statistical scientific methods for radionuclide monitoring. As a trainer and advocate for the dissemination of knowledge on small modular reactors, he actively promotes capacity building and innovation in the nuclear field, and he has contributed to high-level scientific research, notably at the CTBTO Science and Technology Conference, S&T, presenting innovative work on radiation xenon isotopic ratios for nuclear explosion monitoring. So we really have great experts today and great people that are joining us not only by knowledge but also by great hearts and minds. So I would like to pass the floor to Dr. Kulu, and all of you are very welcome today to today's session.
Thank you so much, Florencia, for giving me the floor. I am truly delighted and proud to be part of this major event on the emergence of nuclear. The aim of this event to demystify nuclear science for the benefit of scientists and non-scientists alike. Like it was said, today is day two, and this afternoon sessions will focus on two important topics presented by two impactful young ladies who are committed to the advancement of nuclear science. The first topic will be presented by Mrs. Maria Maso, and it will be about nuclear techniques in the field of human nutrition. Maria Maso is a nutritionist and agri-food engineer specializing in the application of the isotope techniques to human health. Her research focuses on body composition, infant malnutrition, and metabolic diseases. She is also involved in several applied research projects, including the formulation of enriched cereals for malnourished children, the development of yogurt adapted to diabetics, and the nutritional assessment of adolescents living with HIV/AIDS. Committed to the popularization of science and the peaceful applications of nuclear energy in Africa, she is a volunteer with Nuclear Aware Africa, where she works as a nuclear application analyst. Please, Mrs. Mariama, if you are ready, you have the floor. Mrs. Mariama?
Thank you. Yes. Hello. Can you
Yes,
hear
we are
me?
hearing you. But can you speak a little bit more louder, please?
Okay. Florence, can you share your screen, please?
Yeah, sure. Just a minute.
Okay, while Florencia is sharing her screen, I'd like to tell to all the participants to remind that if you have any question for our speakers, please feel free to ask them in the chat, specifying who they are addressed to. Thank you.
So,
Good
Mariam,
morning, everyone.
sorry, your presentation is on the screen, and then just tell me when to move, and then I'll click on the next slide. Thank you.
Okay. Good morning, everyone. My name is Maria Maso, and today I am delighted to share with you a fascinating yet often overlooked subject: nuclear technique in the field of human nutrition. Next slide. Before starting my presentation, let me share with you the outline of my talk. First, I will give a short introduction to explain why we are discussing nuclear techniques in human nutrition. Second, I will highlight why nutrition is so important for health and development. Third, I will introduce the main tools we use, stable isotopes. Then I will present the application of these techniques in nutrition. After that, I will show the impact on public health, and finally, I will discuss some challenges and opportunities and end with a conclusion. Next, please. When we hear the word nuclear, we usually think of energy or even weapons, but there is also a peaceful side, one that saves lives and improves public health. In health, nuclear science is not only about diagnostic or cancer treatment, it also plays a key role in human nutrition, an area that is sometimes underestimated. Why nutrition? Because health is not, next slide, because health is not just about curing disease. Nutrition is a fundamental pillar. It drives growth and development. It prevents chronic disease. It is at the heart of the fight against malnutrition. And isotopic technique allow us to answer crucial questions such as what is a child's real body composition, how much iron or zinc is actually absorbed. Next slide. What are exact energy requirements? In short, better nutrition means better health, and better lives. Next slide. This is where nuclear science contributes so stable isotopes. Unlike radioactive isotopes, they are safe for everyone. The most common ones are deuterium, oxygen 18, nitrogen 15. The principle is to follow the pathway of a molecule, such as water or nutrients, inside the body. For the main application, with these isotopes, we can assess body composition. Next slide. We can assess body composition, evaluate breastfeeding practices, measure energy expenditure, study nutrient absorption, and assess vitamin A. For the application, we have also promotion of good nutritional practices, including breastfeeding and dietary diversification, fortification of widely consumed food with vitamin and minerals, vitamin and mineral supplementation, prevention and treatment of severe and moderate malnutrition, and also treatment of childhood obesity. For the application, we have body composition. For instance, deuterium dilution provides a very accurate distinction between fat mass and lean mass. This is crucial in monitoring child growth and detecting malnutrition. Application 2. We have breastfeeding practices. Next slide. Breastfeeding practices. By using mother-dose deuterium methods, the mother drinks a small amount of labeled water, which mixes with her body water and passes into her breast milk. By analyzing saliva from both mother and infant over 2 weeks, we can determine whether the baby is exclusively breastfed. This method avoids the base of traditional questionnaire. Application 3. We have energy expenditure. To measure daily energy expenditure, we use doubly labeled water. As the body eliminated deuterium and oxygen 18, the rate of decline provides a direct measure of caloric expenditure. It is considered the gold standard worldwide. Application 4. Assessing vitamin A stores. Stable isotope also help assess vitamin A stores, improving the impact of flour fortification programs, supplements, and therapeutic foods. Application 5. We have nutrients absorption. For macronutrients like iron and zinc, labeled isotopes such as iron 57 and zinc 67 allow us to track what is actually absorbed, not just consumed. This provides critical insight for designing more effective nutritional intervention. For the impact of public health, the data generated by these techniques support supplementation and fortification programs, evaluation of intervention, detection and monitoring of malnutrition, and direct contribution to the Sustainable Development Goals like SDG 2, Zero Hunger, SDG 3, Good Health and Well-being. For the challenge and opportunities, of course, there are challenges: cost, technical expertise, and logistics, but the opportunities far outweigh them. These are these tools are precise, safe, and preventive, a cornerstone for modern public health. In conclusion, nuclear science is not only about energy, it is also about life. Next slide. It is also about life. In nutrition, it provides a detailed understanding of metabolism, reliable tools for monitoring, and strong support for public health. In short, nuclear science can promote peace by promoting better nutrition. Thank you very much for your attention.
Thank you so much, Mrs. Mariama, for this detailed and very informative presentation. So in summary, we can conclude that human nutrition is one of the peaceful applications of nuclear energy in the field of health. Nuclear power provides precise and unique tools to this field. These tools are stable isotope and their techniques in body composition, breastfeeding practices, energy expenditure, nutrient absorption, and so on. That Mrs. Mariama have also presented the opportunities and the challenges faced by these fields. And thank you again for this wonderful presentation. So I am looking at the chats, but no questions have been asked yet. I think we can continue. We will wait until the end of the presentation to all the presentations to answer any question that may arise. I think that we can continue.
Doctor
Florencia?
Dr. Cool, sorry for interrupting you. I think I
Yes.
see a couple of questions. Ajisha is asking to
Okay.
Mariama, what is the method of nuclear nutrition used
Okay.
recently?
Okay.
Yes,
I
thank you.
have a connection issue. Yeah, okay. Yes. Sorry. Thank you so much, Florencia. So I have one question. So could the Mariama, the presenter, I think it's Mariama, kindly explain how the isotopes are sourced from a nuclear plant? Mrs. Mariama, can you explain how isotopes are sourced from a nuclear plant? And another question, I think you can take two or three at the same time. In addition to the health benefits, have you tried oral administration of stable isotope for any disease? And what were the results? Do you keep any statistic on this? This question was from Tama, yes. Mrs. Mariama,
Yes,
have you understood the questions?
I am noting the question. The
Should
first
I read them
question,
again?
yes.
Okay. The first question is is if you can explain how the isotopes are sourced from a nuclear plant.
Uh, Isotopes can be produced in different types of nuclear facility. Some stable like deuterium and oxygen-18 are found in water and enriched industrially, not critical.
Okay. And the second question is, in addition to the health benefits, have you tried oral administration of stable isotope for any disease and what were the results? Do you keep any statistics on this?
Yes, recently I wrote body composition with infant malnourished in Senegal.
So another question is, what's this method of nuclear nutrition used recently? I don't know if the question is clear. From Aisha Ali.
Can you repeat, please?
Yes, the question is, was this method of nuclear nutrition used recently?
I use body composition.
So I don't know if the question is very precise. Recently, when or where, maybe Mrs. Aisha Ali.
Maybe if she can open her microphone.
Yes, and ask directly the question because I think it's a little.
Yes, we
We need maybe
we welcome
more
indeed.
precision. Be precise in the question.
Maybe Mrs. Ayesha, if you can raise your hand, and then we'll give you the permission to talk, to
Yes,
raise your question.
if you have any question, you can raise your hand. Okay, Aisha Ali,
Oh,
you have the floor. You can ask directly your question, please.
Hi, I think my microphone. Good evening, everybody. My
Yes.
microphone was muted. Sorry. So my question is, was this method used recently? I mean, uh, after this study has been conducted, let's say for the past 12 months.
Can I
Did
answer?
you, did you understand, Mariama?
She said recently what method I used.
Yes, during the past 12 months.
Yes. Recently I used body composition. Body
Maybe can
composition in Senegal, and we found that children in the north and south of Senegal don't have the same body composition, and children in the south had less fat.
Thank you so much. This answered my question. Thank you.
okay, thank you. And Mrs. Florencia, maybe what about your question? Are you satisfied?
oh, sorry. I think there are other participants under my name, so that's why you.
Okay, okay.
Yes, that's why I was asking the participants if they can just rename themselves, because I know
Okay.
that some of you are joining for multiple devices, but others, if you can just check the settings again and rename yourself, that will be very, very, very useful. Thank.
Yes. As okay. Is there any question to
I think I saw something from Sophia. It's in the Q&A section because some of the questions were dropped in the webinar chat. But if you want to go for it, Dr. Kulu, please. It's from Sophia Rodwane. Have you
um
seen that one?
I cannot see more questions about the isotopes. No. Maybe
Oh, it's
no.
no. Okay, so maybe I can read it. It says, "Thank you, Mariama, for the presentation. My question is, why are some studies focusing on deuterium depleted water and its potential effects on health? Thank you."
Mm.
Can you repeat, please?
Yes, so Sophia is asking, her question is related to why are some studies focusing on deuterium depleted water and its potential effects on health? Thank you.
Some studies focus on stable isotope like deuterium because this is safety. Deuterium is stable isotope, not radioactive. There is no effect with human body.
Okay, okay, great.
Okay.
Thank.
Thank you. Thank you. Is there any other question? Because I cannot see them in the chats. I don't have another question. I think it's all of them.
Indeed, I think we are
Yes.
already covered that. Dr. Kuli, please over to you.
Okay. So thank you again, Mrs. Mariama, for your presentation. And Oh, I think if there are other questions that arise in the chat, we will ask them at the end of all the presentations. So now I think I can give the floor to Dr. Idrissa Wedraogo to moderate the second part of this session. Thank you.
Thank you, Dr. Kulu. As announced by you, today is the second day. As previously announced on day 2, today we will be discussing the theme experimental installation and R&D practice. To speak on this topic, I have the immense pleasure of welcoming Dr. Safa Abdo from Egypt, who holds a PhD in nuclear physics. She currently serves as the executive secretary of WiNI Global Young Generation, and he is a member of expert group of WiNI Global. Dr. Abdo is also certified youth leadership trainer from the Global Alliance of University on Climate and holds a certificate in management and leadership from Cairo University. She leads Nuclear from Climate, an initiative dedicated to promoting nuclear energy as a key solution for climate change, mitigation, and sustainable development. Committed to improving training effectiveness, she has designed and implemented innovative educational strategies in nuclear safeguards and security. Those include problem-based learning, team-based learning, role play, and virtual simulation applied in the training of nuclear safeguard inspectors and security officers. As a researcher, Dr. Abdo has extensive experience in nuclear and environmental science, including the detection of naturally occurring radioactive materials in environmental samples and the use of nuclear and analytical techniques to assess pollution and radioactive levels. Her work emphasizes the peaceful application of nuclear energy, and she has published widely in respected scientific journals. She is also an active advocate for climate change mitigation and sustainability, engaging stakeholders, policymakers, community leaders, and youth in major events such as COP28 and COP39, fostering informed discussion on the role of nuclear energy in environmental protection and sustainable development. Please join me in welcoming Dr. Safa Abdo to the panel. Dr. Safa Abdo, you have the floor.
Thank you, Mr. Adrisa. Can I
You're
share my
welcome.
screen?
Yes, please, Safa.
I think it works now.
We're just waiting to load the slides, maybe full screen mode, and then it will be perfect.
Okay, just let me know, please.
Yes, it is. Now, please go ahead. Thank you.
Hello, everyone. My name is Safa Abdo. I have PhD in nuclear physics from Cairo University, and today I'm going to talk about the experimental installations for in the nuclear industry. So let me just minimize this so I can see my full screen. Yeah. So what are the experimental installation? First of all, my personal opinion is it's something started from the secondary schools, from Geiger Muller in the scientific lab, if you remember. So I will just start my presentation with asking you a question. Please don't see the slide, but think in your mind. What are the experimental installation? Do you think that if your country and especially, as I learned, this is dedicated summer school for newcomer countries. So students are from newcomers. So if your government started to think that they will turn their energy to be nuclear and they want to build nuclear facility, what's the thing the first thing they need to think about? Just like that, produce electricity from nuclear energy and okay, just go and build nuclear plant. What do you think? What's your opinion? I think I can, Florencia, we can see the chat. We can see yes, Aisha.
I guess the first
Uh,
step is to experience, to have an experiment, as you said. Um,
Perfect. Yeah.
to
So
run
what's the
probably
first
sort of,
thing? What's the first thing we should think about? Just to start with nuclear facility, or what do you think?
no, to plan, to study,
To study the
to
site.
study, have a,
To
yes, to have a
to study
rationale
the site?
first.
Of course.
Yes,
Thank you. Thank you. So experimental installation, when you start, Florencia, yeah, go ahead. Yeah, I can hear you, or I'm not the moderator yet. Yeah, Florencia, go ahead.
Good evening, doctor. I think to answer your question, I think the first thing that you have to consider when you are setting up the nuclear site is the availability of water. I'm not sure if I'm thinking right. Thank you.
It's right. It's right. It's right. So, uh, one of you said planning, and this is perfect true. One of you said the site. One of you said the water, or it's the plan. The nuclear facility will be near to like water to be facilitate the next step of cooling and stuff. So here, I don't see if anyone have any answers. Please back me here. The first, Florencia, legalization and regulations. Okay, but it's not the first thing, but it's true. First thing, before legalization, before contact IEA, before anything, I'm talking about you are in your country. As newcomer country, what the first thing? So think about site licensing. Perfect. Hello, my name is Yokolo Nora Mira, Burkina Faso. Okay, it's not for me. So let's continue. Experimental installation specialized nuclear facility for research, safety, testing, and training. So I don't know how to change. Yeah. So what the first thing you come to my mind if you need to build nuclear facility, you have to look for safe place to experiment, test, and train. So your country must establish a set of experimental installation to build local knowledge, train people, ensure nuclear safety. They are not the same as commercial reactor. This is all these things we will see during these 15 minutes or the next 15 minutes. It's not the nuclear reactor for commercial like production, electricity production. This is all the things before this step. So I'm gonna talk about all the stuff we have to do and we have to follow before the decision. Okay, so they are supporting facilities for research, training, verification. That's where experimental installation come in. I hope this idea is very clear because all the next slides will be built on this idea. So what are the experimental installation? By definition, experimental installation are specialized nuclear facilities for research, safety, testing, and training. They don't produce electricity, but provide knowledge, scientific and safety data, training, engineers, operators, regulators, and confidence for government and the public, which is very important thing. I hope all of you in the newcomer countries to believe in this, because when you gain the trust and the trust of the public, everything will go smooth and will go faster. This is something very important, will speed up the process or the progress of nuclear energy, establishment of nuclear facility. So why experimental installations are essential? Safe starting point for large reactors. We can't build large reactors without experience, without trainers, without operators, without well-confident people we can rely on. Number two, regulator foundation. Experimental installation, sorry, Florencia? Okay. Regulation foundation, experimental installation provide real experimental data, not only simulation. Are you hearing? Okay, there is a problem because I see my Florencia.
Yes, Safa. I think some participants are joining under the name, and that's why I tried to request it.
No problem.
Okay, so I was thinking that you are asking this question. Okay, so I
Yeah.
can continue.
There was another participant. She gave her hand a little bit lower. Operator, I think was Katia. I don't know if she still has
Yes.
a question.
Yes, my dear. But first, I would like Dr. Safa to finish, and then I can comment.
Yep.
Thank you so
It's
much.
better.
Thank you.
Okay,
Yes, thank
so
you.
I can continue. Thank you.
Thank you.
So why experimental installation are essential? They are safe start point for before building any large reactor. Regulatory foundation, experimental installation provide real experimental data, not only simulation. And all of you, if you are here engineering, you know that we build our data on some theoretical data. We build our like codes in this data, but we need to start on real, like from real data, experimental data. So we can't just build our reactor on just theoretical simulation model. So number three, technology development, testing new fuels and materials, of course, human capital training, the national workforce, which is very essential, public confidence, as I told you before, demonstrating nuclear benefits in medicine and industry. I will like explain furthermore how can, if we start with medicine, if we start with the benefit of nuclear energy in the industry, it will lead us for big like facility, and then we can turn to work with electricity, to produce electricity. So here I just put some experimental installation in newcomer countries. Egypt, our not it's our reactor since 1997. Multiple purpose reactor for material testing, isotope production, and training. Strong foundation that helped Egypt launch الضبعة, a nuclear power plant project with Russia. Another example from the newcomer also, Jordan, in 2016, built before any power reactor. They used their reactor for training, isotope production, and material testing. Also, it's the foundation for Jordan nuclear development, and till now they just like putting plan. As I learned from one of the expertise I met in Vienna, they said it's like under it's in the like period of preparation. They just put the plan for the real reactor for producing power or electricity. So in 2016 till now, like 9 years, they are just focusing on building their expertise, their capabilities in nuclear research reactor. So another for example, Morocco in 2007, they used their reactor like basically in education, training, and in isotope production. Also, it helped their public trust, build public trust, and showing nuclear role in medicine and agriculture. And we have here in Women Global also an expert in this from Morocco, of course, Dr. Nuzha. So key point for newcomers, start small, think big, research training reactors first. So we have to start, this is like map. This is the best way to start. I know there is another example for people, for country will start like directly with producing electricity. But in my personal opinion, and in IEA opinion, in expert opinion, it's gradually the best way. So build skills locally, avoid dependence on foreign experts, support regulator, provide real experimental data, provide your own national data. Earn trust, as I told you before, and this is very important for me, earn trust, highlight medical and industrial benefits. So types of experimental installations, it's very large, very vast, but I picked here the important, yeah, I saw someone, okay, is asking. Hello?
I think it was for a few seconds, but maybe we can.
Okay, but someone, yeah, Lancio is raising his hand. Okay, so
I'm so sorry. You can continue.
I just
You can continue. I'm so sorry. I continue. I'm so sorry.
Okay, no worries. Okay, so here, types of experimental installation, critical assemblies, hot cells, irradiation facilities, research reactors, which I consider the most important because it can cover like 3 types in the same time, radiochemistries, isotopes and labs, radiation protection dosimetry facility, waste management experiment facilities, and finally simulator and training platforms. So, what are the critical and subcritical assemblies? By definition, critical assemblies, very low power research reactor, designed just to self-sustain chain reactor. We want to just like test and test the critical value of the reactor, K effective. I know that you know more than me in this field. And subcritical assemblies contain nuclear fuel but cannot sustain chain reactor on their own. They require an external neutron source, such as neutron generator, to study neutron interaction safely. So, main purpose of the critical assembly, conduct reactor physics experiment. We want to study the reactor physics, which contain, first one, some purposes of critical assembly, measure fundamental nuclear parameters, neutron flux distribution, multiplication factor KF, test new fuel types, core configuration before using them in larger reactors, which is the commercial one. Neutron behavior studies. So engineers want to observe how neutron move through different moderator materials, graphite, heavy water, light water. Every like type of moderator has to be tested by engineer, and with this small non-power, at least no output power, no heat, and you can test the validity and the productivity of and the reactivity also of the moderators, different moderators. Number 4, study control road worth, reactivity coefficient, safety emergence, training, education. Provide hands-on training for nuclear engineering, reactor physicists, and regulators in a safe environment. So, why should we study reactor physics? Why? First one, it is an ideal start for newcomer countries to build first generation of experts. You can just import the expert from outside, because you need to build your own expert, your own engineers and operators. They live in this country, and they have this commitment to this country. So you have to build your own generation of experts. Number 2, validate the computer codes. Nuclear power plant design relies heavily on computer simulation. And of course, you know that MCNB code, Gent 4, all these codes, you can just stay, sit on your desk and build a nuclear reactor in front of you in your computer. But this is not the real life application. When you use this, you will save time, save energy, save money, of course, but you need to input this codes with experimental real data. which come from research reactor, critical assembly, and so on. So number 3, critical assembly supply benchmark experimental data to check accuracy of neutron transport and reactor physics codes. You know, in MCNB, maybe some of you know this code because I was working on this code. It's neutron transport and reactor physics. We were studying how neutron behave in different media. So number 4, fuel development. Also, they used biofuel engineers to study new uranium or thorium fuel compositions or mix, MUOX. So here, international, reactor physics experiment. I just put here for you some example, some from East and West, from East, I mean East countries in Pakistan, like Iran, and some laboratories in America. So Idaho National Laboratory also used their like they have this experiments. They measured all these. They test all this material, and then they provide the nuclear reactors where they finally put this real data for testing, and then they produce electricity. So the first step is from Idaho National Laboratory, from Aragon National Laboratory. So we have also Pakistan also critical assembly. They use reactor physics experiment and training. Also Iran, they built critical assembly in Tehran in nuclear research center, also used for training. So research reactor is the most important part of the nuclear installation or experimental installation in nuclear industry. What they are by definition? They are nuclear reactor operated at low to medium power from few hundreds to also few kilowatts. So unlike power reactors, the one we want to build, it's not now built. You are with me now in this journey. We didn't build the reactor till now. So unlike power reactors, they are not designed for electricity production. Their purpose is to provide neutron for experiment, training, publication in science and medicine and industry. The main purpose of research reactor. First one is education and training. And because here, this summer school is dedicated for newcomers. So please, education, then education, then education. So train nuclear engineers, operators, regulators, and students. Hands-on experience with reactor startup, shutdown, control road, neutron flux measurements. So first step for newcomer countries is to build a skilled workforce. Number 2, reactor physics experiment, as I talked before, study neutron flux distribution, reactivity coefficient, control road work, validate reactor physics codes, also support design of power reactor by providing benchmark data, real experimental data, not just theoretical data. Number 3, radioisotope production, produced medical isotopes. Of course, this is very important because here in Egypt, in Syria, in Morocco, all the research reactor, the main and essential benefit of the research reactor is produce isotopes for medical application. Supply industry and agriculture with isotopes for sterilization, radiography, and food preservation. Material and fuel testing, irradiation samples of fuel and structure materials, study radiation damage, corrosion, performance in real neutron environment. So essential nuclear research are essential before scaling up to nuclear power plant. You have to start with research reactor. Number 5, scientific research, neutron scattering experiment to study materials that at the atomic level, of course, application in condensed matter physics, chemistry, biology, environment, everywhere. Public regulatory confidence, as I said before, if you start with industry and medicine, people will gain trust, you will gain trust of public, and they will have this confidence of you because you cure their patients. They will believe in nuclear energy. Example, we have IBR2 in Dubna in Russia. This is the reactor I was working with. And we have Anshas in Egypt. And we have Jordan Research Training Reactor, as I told you before. They built it in 2016. We have Safari in South Africa. Also, it's research reactor. And we have in Australia and in America. Hot cells. What are the hot cells? Here in Egypt also, we called it in Arabic, it's very like frightening name, hot cells. Hot cells are heavily shielded laboratories designed to handle, process, and study heavily radioactive materials like irradiated nuclear fuel or isotopes. Of course, if one of you asked how we study the nuclear material after they are very irradiated and come out from the reactor. How can, if I covered myself with any cover, with any shield, no, it will attack me. Okay, so here the hot cells come. Operators will work remotely using thick lead glass window, manipulator, or robotic arms, since direct human access here is lethal, of course. Shielding is usually concrete walls up to 2 meters thick, lead, or steel, depending on radiation intensity. You can see here from the picture, but I tried to cover the man face. So main purpose of the hot cell, post-irradiation examination. As I told you, analyze nuclear fuel has been irradiated in reactor. Of course, you can't touch it with whatever you put in your hand or cover it in your hand. You can't touch this irradiated material. So you have to put it in this hot cells and treat with this material with robot. Study how fuel pellets, cladding, and materials behavior under radiation and heat helps improve fuel safety and efficiency, radioisotopes production and processing, safety extract, purify, and package medical isotopes, support agriculture and industrial application, waste management research, of course, and developed safe methods of cutting, encapsulating, and condition radioactive waste. Test new storage and disposal techniques, nuclear forensics safeguards. We can talk in each one of them separately if we have time. And training, capacity building, allow nuclear scientists and engineers to gain hands-on skills to remote handling, radiochemistry, and radioactive waste management. So, irradiation facility, what are they? Irradiation facility are specialized installation that expose material to products to control radiation. Here, I think there is a question in the Q&A question in the past presentation. They asked how they produce the isotopes for medicine. We use irradiation facility, two types of irradiation facility, if you want by neutrons or by gamma. Depending on this facility, they will produce the isotopes, which will use after that for medical application, treatment or photography or whatever. So we can also in industry test metals, ceramic, fuels for advanced reactors and fusion. Of course, if we want to study that different type of shielding, we have to put this material in front of radiation, in front of pressure, in front of heat, and study the different and the harsh condition of this material, so we can have this data or this experimental data and validate this material for shielding. So main purpose and function. Material testing and development, the first for irradiation facility is to study how metals, alloys, ceramic, concrete behave under neutron flux and radiation. Evaluate swelling, corrosion, and structure changes. As I told you, if we put them under harsh condition. Essential for designing safe and durable power reactor component, nuclear fuel testing, irradiate experimental fuel rods, or pellets under real neutron condition, assess performance, burn up, and safety margin before industrial use. Number 5, radioisotope production. Irradiate target material to produce isotopes for medicine, agriculture, and industry. Neutron activation analysis, a precise analytical technique where samples are irradiated to identify trace or minor elements. It's widely used in environment, geology, archaeology, forensic, and quality controls because it's very, very specific. Can you imagine that the accuracy of neutron activation analysis, it reach 10 to the power minus 14. So you can imagine how much this is very useful and very precise. That's why it's used for quality control. Number 7, industry application, gamma radiation facility using cobalt-60 sterilized medical equipment, pharmaceutical, and food production. And you can imagine how much this saves time and money when they use cobalt to sterilization. Safety validation and licensing support. What it mean? What does mean? I think one of you wrote in the legalization, wrote in the chat. Experimental installation provide the scientific data and benchmark the nuclear regulator need to evaluate the licensed reactor safely. So how can I regulate these people? How can I give these people to become licensees? Before doing that, we need experimental installation to provide us with this experimental scientific data. How it is done? First, critical and subcritical assemblies test physics models, neutron behavior and reactivity, data compared after that by computer simulation, and then, of course, used in the reactor design. Number 3, research reactors simulate accident scenarios, testing safety system. Okay, we can't like face or subject the real nuclear plant for the real condition, but we can create similar real condition for disaster in the nuclear research and study how this on the small, very small scale, I mean, because I know the output is not more than 22 megawatt. So I want to see how it will develop and how people will react, how our team will react with this disaster or with this. I will create this scenario in the experimental installation. So why it's important? Regulator and licensing authorities need real experimental data to confirm that proposed nuclear power plants are behaved safely. Number 2, build public confidence in nuclear safety. And this is the third time I mentioned the public confidence because we are newcomer and this is very important for us. So reduces resilience on foreign data, giving newcomer countries their own national database for safety analysis. Here, I just put the radiochemistry isotopes labs, and I just want to highlight the benefits of medical application in nuclear industry. But it's not like very important here because our friend already talked about them. I can say in summarize, what are they? They specialized laboratories in experimental installation, just specialized for radioactive materials and isotopes. They learn people in this facility how to handle, how to process, how to profile, the isotopes. So they extract the medical isotopes like iodine, it's used for thyroid maybe cancer, and cobalt-60 from target irradiation in research reactor. And by the way, Egypt is like exporting these isotopes to the country around us. So conduct radiochemical analysis of sample for environmental monitoring, nuclear forensic, and reactor studies, support agriculture. Also, we have this application in agriculture as an industry. And by the way, we have, if you want, after the class, I can give you like full reference. You can study the application in agriculture and medicine from IEA. It's a long series, but it's very, very like useful and very informative. if you find this like very good topic for you, I can drop you the reference and you can find it delicious. So these laboratories provide visible benefits of nuclear technology to the public, health, agriculture, industry. As I told you, if you see that your patients are cured because of nuclear energy, you will start believing in nuclear energy. Train chemists and technicians in safe handling of radioactive substance strengthen national self-reliance by reducing dependence on imported isotopes. Of course, sometimes people rely on their neighbors to bring them isotopes, but sometimes isotopes like half-lives like 3 days, so you can or 1.5, so you can export them. You just produce them and use them in your country. So you can see from what I am saying now that you have to build your own national laboratories to produce your own isotopes. Radiation protection dosimetry, after all, we are playing with radiation now. So we have to like test and monitor the radiation comes from the reactor. So what are they? The radiation protection dosimetry facilities in the experimental are very essential in the nuclear experimental installation. They are laboratories dedicated to measuring, monitoring, calibrating radiation exposure. Their main function, calibrate radiation detection equipment, starting from Geiger counter. I don't know if in your high school was Geiger-Müller or not, but in mine was. So I start now hearing the tick, tick, tick of Geiger-Müller. So I think experimental installation, it's not starting from nuclear industry, it starts from high school. Number 3, develop radiation protection standards and monitor occupation exposure, provide emergency response capabilities for radiation accident, and conduct research in shielding materials and radiation transport. If you can see this picture of TLD, if you have been in at radiation protection dosimetry, I don't know, at IEA or in your country, you can see that the safeguard always put this badge in their chest. Of course, you see those people, it's TLD, it's dosimetry, they measure it every once, 3 months, and every year, and they have just limited value. It's, I think, if I can recall, it's 1 millisievert per year. Correct me if it's wrong. This is the maximum you can accumulate during the whole year. If you exceeded this like value, you will be excluded from working in this area at all. That's what is very important, this laboratory. Essential for protection workers, public, ensure compliance with IEA basic safety. I think I am hitting myself in the talking. Build public trust that nuclear activities are safe. Example, we have an example from IEA and example in Egypt, in National Center for Radiation Research and Technology. And of course you have in your country, but I put mine and you have of course yours. Safety validation and licensing regulators need real experimental data. Again, safety validation, we need real experimental data. We can't just rely on simulators and codes. They save time and money, but not everything. Verification that design, equipment, and producer meet definite safety requirement, licensing, authorization, regulatory approved process granting permission to constructed operate or modify experimental facility, hazard analysis, identification and assessment of radiological, chemical, mechanical, and environmental risks. Design validation demonstrate that the facility satisfies performance and safety requirements under expected conditions. So, as IEA put for this country, if you have this, yes, you can build a nuclear facility, you have this code book, you have to follow this book to follow this verification and validation code. And how can you meet this criteria? Because you have your own national experimental installation for your nuclear industry, and you can test your material, you can test your worker, operator, everything. And accident scenario, I talked about them, and defense in depth. How can we evaluate multiple layers of safety barriers and emergency response? So waste management, experimental facilities, what are they? I am sorry if I am taking too long, but this is the shortest thing I could prepare. What they are: pilot scale facilities and labs designed to study how to handle, treat, condition, and safely store radioactive wastes. What's the first thing come in your mind when I said I will build nuclear, or your government, of course, it's not mine, but your government will build nuclear reactor for your country? You are educated, not educated, you are one man in the street, you will ask him, he will say nuclear wastes, radioactive wastes. This is the main thing that, like the main concern for the public, where they go, sorry. So in these laboratories, developed waste condition method, cementation, vitrification, compactation, study storage materials, containers for long-term safety, test decontamination and remediation techniques for contaminated equipment or soils. Of course, during the year, you will face some problems. You will face some spill. Maybe, I'm not talking about number 1 category, maybe number 3 or 4. So train specialists in nuclear waste handling and transport. Of course, you have to have your own trainers in this field. So why it's important? Radioactive waste management is one of the biggest public concern about nuclear energy, as I told you before. Number 2, provide safe practice for medical, research, and industrial radioactive source. Build a national strategy for long-term disposal for spent fuel and waste. Example, in Egypt, we have hot laboratories, we have waste management center in Anshas, because our research reactor where in Inshas is in Inshas, manages research. This is like a name of area. Manages research reactor wastes and conduct waste embolization and radiation, of course, and development. So this is a very like catchy slide about simulators and training platform. This is like screenshot from MCNB and from Gent4, from multiple like simulation codes, but you can trust them, but for for a degree, like not 100%. They are essential. They are considering as invisible backbone of a nuclear program. Advanced digital or hybrid, sometimes digital plus, of course, as I told you before, robotic or physical part, systems that mimic the behavior of nuclear reactors or their nuclear facilities. I can't run an experiment like 1,000 times, but I can did it with nuclear codes. I did my PhD. I did I conduct like how can I say this? Like shielding for a room, and I put this gamma ray. So when I ran the program, the code, I ran it for 1,000 times. I can put the computer open and go to sleep and come back again after maybe 3 hours, 4 hours. We can't do this in experimental life 1,000 times. We can, it's like time consumption, money, everything. So
sorry for interrupting you. Maybe if you can just wrap up quickly. I know that you still have things to cover, but it would be nice if we just try to speed up this. Thank you so much. I'm sorry for interrupting you.
No. Okay. So now we have this example about simulators, and we can see how they are very important, but not everything. So simulators, training platforms, we can train people on them and then apply in real life, like once, and in the simulation model 1,000 times. So I can just go to the final slide about education and training platform. From previous installation, we can conclude that what it's, in short, research reactor allow trainers and operators to practice startup, shutdown, control route, movement, neutron flux. This is all important. Simulators also provide very important information for the trainer, but why they are together, very important. Build national human capacity for nuclear technology, especially for newcomers, reduces dependence of foreign experts, creates safety-first culture from the very beginning of the nuclear program. So, nuclear power cannot be built on theory alone. It needs a foundation of experimental data and training. Experimental installation are that foundation. They are testing grounds of safety, classroom of engineering. This is the summary of today's presentation, and the laboratories of innovation. Thank you. This is my information. If you have any another question, I am happy to
Thank
reply.
you, Dr.
So I can stop my yeah, I can stop my, just give me a second.
Thank you, Dr. Abdo. Thank you very much for that excellent presentation. We have just here how experimental installation play a central role in the nuclear industry. They are not designed for large-scale electricity production, but rather to test, train, innovate, and validate the concept that will shape the nuclear sector of tomorrow. They include a wide range of facilities, research reactor for materials testing, isotope production, and training. Specialized laboratories and hot cells for analyzing irradiated fuel. Fuel cycle pilot plants for enrichment, fabrication, and reprocessing. Major fusion project and accelerator exploring future technologies. Was Management and Decommissioning Center for Cell Long-Term Solution. Radio protection and dosimetry facilities for protecting workers and environment, and simulator and mock-ups to ensure training and operational readiness. It also highlighted that research and innovation go hand in hand with international cooperation. In summary, those infrastructures are two pillars of research, safety, and capacity building. They advance scientific knowledge, support industrial innovation, and prepare the next generation of nuclear specialties. Thank you. With that in mind, I would now like to open the discussion. If you have a question or a comment, please feel free to raise your hand and go straight in chat. And let's make this an interactive exchange where we can all learn from each other. Is it okay?
I didn't understand. I'm sorry. Just let me know.
Okay.
There is a lot of questions in the chat. I see 3 questions also in the Q&A. So I don't know. Maybe I can read them.
Okay.
If you can. Okay, Florencia, I can read them.
Dr. Abdo explains the topic so enthusiastically. I really appreciate the chance to hear her presentation. Is there a place in the experience to reinforce the youth development in nuclear investigation, or has she related to information in a global perspective of nuclear energy education that Latin American can also relate to? Greeting from Mexico. The second question.
Okay, okay, the question is very long,
Okay.
so I can, Florencia, I can read the questions because it's very long. Okay, I will start I will start. Okay, please, who is in charge of waste management, the government facility or the producer of equipment? Of course, the government is the facility. You can't build the nuclear plant without the government. So it's the same. the same coin, like two faces for the same coin. So thank you for the, I can't, okay, informative message.
We have another one for digital program
My
platform
question
that it
is,
is
do we
accessible.
have digital program platform? Yes, we have. We can run everything. We have some paid, like MCNB, which I worked with, but Gent 4 is like open. It's for free and open. But the problem is you have to learn C++. So if you are willing to work in this field, start with learning C++, and then you can find it's free and open, and it's produced by CERN. CERN in Sweden, maybe it's yeah.
It's Switzerland. One more comment. I mean, in HPC or high performance computing, there's also used Python, CUDA, and different modules of other language in programming. So try to get those tools that are open source normally, because some it depends from the country that you're working. Some are authorized, others not.
Yeah,
So
and of course, especially for medical use, there is Gamos. I know people from Cuba, from Latin America, they working with Gamos, and it's free. And it's like Gamos. You can write in your GAMOS. It's free and it's specialized for medical uses. So all people can like build human phantom, and test different radiation isotopes, everything. It's Gamos, and I know people work from Cuba, and it's free. So thank you for it must first have through
Second
understanding.
question, Sophia Radwan. Thank you, Safa, for the presentation. My question is, what are the differences between a nuclear power plant for electricity production and research reactor? Thank you.
The difference?
The difference
So
between
yeah.
nuclear power plants
Thank you.
and research reactor.
So as I said in the first presentation, in the first slide, research reactor is the benchmark for the electrical, commercial reactor. Research reactor is small with limited output, don't exceed like a few hundred of megawatt. The examples I put in my slide, like the maximum was 22 megawatt. The one in Russia is 100, but it's not stable because it's fast neutron reactor. So I'm telling you, it's two different things, but it is essential step before commercial reactor. You have to start with research reactor to validate yourself, to build your own trainer, your own engineers, and to train them. After that, you can think big and go to the commercial reactor. So this is the research reactor is the heart of the experimental installation in nuclear physics, in nuclear industry.
Just for the record of the participants, I share some of the relevant publications and links directed to the IEA website in terms of evaluation of physical protection, nuclear installations, and so on. Maybe if you would like to collect additional information from those, you can jump on that. And I would like just to wrap up on this. We still have some questions that are not answered yet, but maybe if I direct them through you personally, you take the time and you let us know what are the best responses to the audience, and then we also give them the file that you can type your questions or any other relevant material that you want to share. Is it okay for you? Because we are exceeding the
Have no
expected
problem,
time.
and you can, yeah, and I share my email, and in the last slide, you can just send me the question or send it to Florencia. I will reply, like I'm
Yes,
glad to help and reply, of course.
it's a good way.
Okay. Thank you so much, and we're very sorry for exceeding the expected time. I know the discussion was very, very great, and all the materials that you presented. We will share all the slides of all the all the speakers once that the school is finished. So all these material that you're seeing from Safa and the rest of the speakers that are coming, everything will be there, and also the recordings will be available in the YouTube channel of Win Global organization. So
I have question now, Florencia. The questions in the chat will be saved or will gone because they are very important. Please.
I'll copy and
Yeah.
paste them and then send them to you.
Yeah,
I'll
I
just compile
feel,
them in a file and then
yeah,
I'll send it.
please, because I feel it's very important. They are asking very like in the core. Yeah. Thank
No,
you.
no, no. Indeed, I'll just compile everything and materials, links in detail. Please just don't hesitate, and I'll just share this with the participants. Okay.
Thank you. Thank you, all of you.
Thank you. Over to you, Dr. Idrisa, and
No, nothing to say. Thank you.
okay. So this is the end of today's session. I know that we're still having a lot of things to discuss, and this topic has been so much important because it's nuclear. Experimental installations is like one of the milestones and key steps in the nuclear development projects. Please bear with us this exciting time, and let's just gather tomorrow for the third day of our summer school. And we hope that you're finding very fruitful the program. Also, I dropped it in the link on the chat. If you can just register one more time, because I know that some of you are utilizing your personal name, but others are replicating my name or others participants' name, and it's really hard for us to mark the attendance of today. So if you can just make sure by tomorrow when you log in into the session, you type or you verify that you are entering with your own name, please. We will appreciate that. And we're very sorry because yesterday was not the best time where we cannot gather everyone on the same room. We have some limited space in the Zoom platform, but today we are making it better. So thank you very much all. And I think we have just one last comment from Katia. Do you have some comments related to the
Mm,
dynamics or logistics?
she's raising her hand. I don't know.
Me neither. Okay.
Okay.
So thank you very much for today. This is the end of today, and please be safe. We wish you to have very rest of your day, evening, depending where you are, and thank you for staying with us.
We
Thank
finished
you.
already day.
Yeah. Thank you so
Bye.
much. Have a very good day.
Really awesome
Thank you. Thank you.
presentation. It's exciting to hear and see all the work that We Planet is doing
Thank
in
you.
Africa broadly and specifically for nuclear energy. So thank you for the presentation.
Thank you.